Quickly Twitch catches on that we're streaming. Okay, Twitch is aware that we are streaming. Guess I will tell the world. Streaming game dev. Gonna make noises into microphones. And then I'll pop over here and tell these nice folks as well. And then we will just hop on over here so that we don't eat up all of our RAM. Alright, so we have a game that's basically functional, and it's not really a game yet, but the basic tech is functional. What I'd like to do is I'd like to spend some time making it a little bit more fun. And a big part of that is going to be adding some noise to all of the engines and stuff. Now for now I'm just going to make some dumb mouth noises, and that will be our noise. It's a fairly noisy day, both outside and inside, so I don't expect these to come out very well. But I just need to figure out what... Oh, there it is, Audacity. I always forget Audacity's name. I have no idea why. You think it would be super easy to remember. But I can use Audacity to create files and that sort of stuff. I'm going to go ahead and pop open the audio directory. And that's going to be where we stick our various noises. Hold on just a second while I send you over to Phoenix Wright for just a minute here. Hold on, I have to do this. Bleh. And then we'll just pop on over into... is Audacity the one that actually doesn't let you paste in a location because it is just... Okay, there we are. So we're going to have... Blip. We'll just call this... There, now it's pointed the right place. And I can pull this back here. Back to the screen. Alright, so if you can't hear the audio, I'm going to try and keep it balanced so you can hear the playback, but let me know whether or not that works. And other than that, let's go ahead and make some noises. Some of the noises we need are going to be for the engine. That's basically the biggest one. Let's go ahead and turn off my heater. It is very cold out. And we're going to go ahead and just go make some noise straight into the mic. What sort of noises do engines make? They actually make a noise very similar to the heater, but it would be difficult to hold it up to the mic and get a loud result. Or would it? This one doesn't have any... Oh, I can't quite make it. Cord's not long enough. I don't feel like fussing around trying to hold something up to the mic like that. I'll just make dumb mouth noises and then modify them. How exciting, right? Let's go ahead and stop and pull that over here so you can see me do what passes for editing. I will just delete all of the extra crap here, which I can do just by hitting delete. Now, I'm not a pro at Audacity by any means, but it's a pretty basic program. There shouldn't be any difficulty in just making it do basic stuff. Let's go ahead and see how the balance turns out when I look at it. Yeah, that's balanced at about the right volume for you to hear it, I think. It's a little bit hard to tell. But obviously we don't want it to sound quite that obvious. I don't care if it sounds dumb or silly, but I don't want it to sound so distracting that it is, just terrible. So what we're going to do is we're going to go and just add in a bunch of modifiers to try and get it that's going up. I want it to go down. There we are. Bunch of modifiers to try and get it to sound a little bit more engine-like. Now, the other problem we're going to have is that this has a beginning, a middle, and an end, and we obviously don't actually want it to do that. So what we're going to do is we're going to chop off some elements here, And then we're going to duplicate this entire audio track, which we can do just by Control-C and Control-V, right? No? Edit. How do I paste it into a new audio track? I know you can. There we are. And then what we'll do is we'll reverse the second one. No, I don't want to reverse both. I only want to reverse one. Why is it reversing both? I only want to reverse one of them. Can I mute this one? Will that help? Just reverse one clip. That didn't help. Wow, that's obnoxious. All right, so can we have two projects open at the same time? We can. So we'll paste it in here, and we'll reverse it over here. And then we'll copy this. It plays backwards. Okay, that's interesting. We're going to delete this guy. Nope, don't want to delete them both. Just want to delete one of them. Paste it in. And now it should be... no, hold on. When I pasted it pasted it in unreversed. Come on, zoom in, would you? Why are you way zoomed out? Wow, I did something wrong here. Let's delete that. Nope, just this one. Wow, I do not know how to use Audacity. This is going to be a fun situation for you folks, I'm sure. So I'll paste that in. Okay, so that should be reversed properly. Yeah, so I don't know what happened the first 800 times. Yeah, that's a decent engine noise. So we're going to go ahead and export that and put it into our directory and then load it up so that when the engines fire, they make that noise. Engine grumble. Hold on, I actually want to export engine grumble as something besides wave. There's no reason to leave it as a wave. It'll be internally compressed. Something besides MP3, rather. There's no reason to leave it as an MP3. It'll be internally compressed. So there's, not any real reason to compress it. I'll just save it as a wave file. I believe that is fine. So we'll kind of call this engine grumble. You got an engine grumble for me? Yeah, and the blep test, that's fine too. All right, so now that we've got this engine grumble, we're going to want to just make sure that it sounds the same in here as it did out there. Yeah, so if we loop that, perfect. So, of course, now the question is, how do we get that sound to play? Well, we have a system for playing sounds already, and it is when we thump into something, we spawn a new thump sound relative to the camera based on where the ship got hit relative to the ship. And that's not a bad idea, but for the engine, main engine noises, it may just be better to have an overall sound manager. If we pop over here into the engine, come on engine, there we are. These actually have a an on ready state, an on throttle changed, which is a single. Now if we hook up an audio sound to that, we can simply turn it on and then let it run and turn the volume to the throttle level. Now it's a little bit lossy because there's so many elements here that don't quite work, and we'd be playing something at 0 volume all the time. But let's go ahead and just turn it on for starters. So here's an audio source, and we're going to just drop our engine grumble in there, play on awake, loop, and we'll start with the volume at 0. Now we're going to want this to have a 3D spatial blend, but I think that this distance roll-off is pretty strict. I doubt we'll even be able to hear it. We'll go ahead and try it, though. Actually, let's go ahead and set the volume to 1 just so that we can see if we can hear it. We can hear it, but it's very faint. So we're going to want to make this a little bit different. We'll make this 50 to 1,000 and see whether or not that overwhelms the audio from the background song. That's probably about right. We'll probably adjust it some more later on. But what we're going to do is we're going to have this audio source get its volume adjusted. The problem is that that's not going to be something that works directly. And the reason for that is because we are going to have the ability for us to edit the global audio level in the options menu. And I can't do that if there is no thing that goes between our engine and our audio. Elboy just says it sounded weird. Yeah, that's because I've got the automatic stuff for the 3D stuff, for the 3D sound effects includes a Doppler effect. It's not going to sound like that in the final mix, don't worry, because it's not going to be turned on that quickly. But what we do need to do is create a very simple script that will move an audio source volume based on an audio source cue. Now we have a couple of options for that, but we're going to go ahead and make this an audio source specific option. So we're going to call this an audio regulator. We'll just drop our audio regulator and the audio source. There. Audio regulator. So Jamie Tech Tip says, hey, do you know how to make a playable character and mesh? I sure do. That is something that you really need to learn at least a little bit of if you're going to do anything in Unity. Unity comes with some built-in player stuff that you can use for your projects if you don't mind your projects looking pretty samey. Making it yourself involves both modeling, rigging, both. There's like 8 things. It involves modeling, rigging, and creating a character animation system. And those are all really annoying. So unless you feel like spending all of your time doing character work, you're probably going to want to get a character somewhere, just because otherwise it is a lot of work. Even if you finish with the actual model, you'll still need to make all the animations. If you're just getting started, get started with something that already exists. Public void regulate float throttle. And what we're going to want to do here is grab the float, what's it called? Audio volume, global audio volume. And then here in start, we're going to want to do refresh, and we're going to want to sign up for a change to our settings. Okay, so what did I call it then? Hold on a moment. I've got to remember what I named the settings. Colt Zero stopped in. Hello. We're doing audio today, and we are going to make a bunch of elements for this. And I called it an options menu, didn't I? Options. Yeah, there it is. Options dot on settings updated dot add listener refresh. Yeah. Void public void refresh. And in refresh, what we do is we set our global audio volume. We don't want to do that every frame because it might happen hundreds of times a frame, and that would be annoying. Global audio volume equals options.getFloat audio volume. Now, we're going to need an audio volume here in our options menu. And to do that, we're just going to go ahead and grab this music volume and duplicate it. Except for we actually want to duplicate the whole panel. There we are. And this is going to be our general audio. So audio volume. And we're just going to come down here, audio volume. I'm learning how to make tessellation shaders, Colt0 says. First time learning tessellation, oddly enough. Well, tessellation is relatively recent in terms of its support on the hardware. It's a fun thing to do, and it takes a lot of advantages of the same things that GPU instancing takes advantage of. It all happens right there on the GPU. I haven't done a whole lot with tessellation shaders myself because I haven't needed a lot of extra geometry. Not for a couple of years now. So that's going to be our audio volume. That should all work fine. Now all we need to do is here in Regulate, we're going to want to have a public audio source, target audio source. And then we'll say target audio source dot volume equals throttle. We'll say if throttle equals 0, is less than or equal to 0, and throttle, hold on a minute. I think we can go negative, so we're going to go ahead and just say that throttle equals math.abs throttle. Colt0 asks, what are the good applications of tessellation? Well, my favorite application of tessellation is to get away from voxels, but I haven't done voxels in ages. If you have something that is voxely, you can use tessellation to automatically increase the detail of the surface just by having the tessellation change based on how close you are to the surface. And that works fairly well. It lets you do a basic surface topology without having to use voxels. Another useful thing in tessellation is for creating things like smoke effects or fire effects. I really like the effects where the tessellation is not constant, but it comes and goes. If it's a constant tessellation, I mean, you can save some draw speed, but I'm not sure that I would have much preference for that over actually having the mesh have that density. But tessellation is really, really useful for things where it's like a different kind of LOD, in my mind. I know that other people use it for other things. If throttle equals 0, then target audio source dot play is a stop. So if throttle equals 0, and target audio source is playing, else if throttle does not equal 0 and target audio source is not playing, then play. Colt0, I'm sure that he has his own goals for his tessellation shaders, or maybe he's just investigating for kicks. But I have to remind you that I've never actually bothered to create one all the way through. I just did testing. So don't take my word as some kind of magic information from on high here. All right, so here in the audio volume, we're going to go ahead and audio source, here it is. I'm going to go ahead and set this up so that it works. Just drop this in, set the volume to 0. And then what we'll do is here in the rocket thruster, we'll set up this rocket thruster with an on single. This guy is going to light up the audio source. I accidentally hit a button and it opened up Twitter on the other screen in a very strange way. That was fascinating. Anyway, the audio source that we're going to want to do is regulate. Here we are. Now that should work. If we hit apply, the only problem with hitting apply there is it might change the name of a whole bunch of other rocket thrusters, but it's not that big a deal. Now these should all have been added in with an audio source, and now they should all have audio sources. Hooray! Jamie Tech Tip says he's making a platformer game. And it looks like it's a 3D platformer. Well, in that case, you're going to want a third-person character controller, and that's the most difficult type. So you have your work cut out for you, I'm afraid. Now, Unity does have a character controller built into it, so if you were just moving around a ball or something, you can slap a character controller onto it and Unity's built-in character controller will work fine. But if you're trying to animate your own character, you have to realize that you have to model the character and texture the character and rig the character and animate the character and build an animation controller with all these states in it, and it's really, really tough. It's just a lot of work. So let's see whether this worked. I don't know if I would call it a convincing... I don't know if I would call it a convincing effect. Now, one of the issues we're having is that the front engine is also making the noise. And since it's the same noise amount, it sort of is hard to tell what's going on. So what we're going to do to fix that is we're going to move the audio source back away from the engine a substantial amount. And we're going to reduce the max distance to 500. And then we're going to go ahead and apply that change. Yeah, Boichi asks if it's a didgeridoo. No, it's just me. I just made mouth noises. So clearly this is not really working. Let's pull it back even further. The problem is that the reverse engine is the same volume. I really want a volume cone rather than a sphere. It's kind of obnoxious that it is stuck as a sphere all the time, although it makes sense, obviously. That's kind of what it's like. The other thing I'm going to do is I'm going to square the throttle, which means I can just do throttle times equals throttle. Now another solution would be to have a different engine for reverse thrust. I am actually really shocked at how annoying this is to me, and the reason it's so annoying is because the volume, the sounds aren't happening relative to our... they're happening relative to the ship rather than relative to the camera, and that's a no-good. So that's a no-go rather. So what I really should do is move those audio sources onto the camera. Now I can do that just by dragging them over in this case because we're playing fast and loose, but that's really dumb. So I'm going to do that, but I'm going to do that with the understanding that that is just about as dumb as you can get. So we'll just drop all of this stuff onto the camera here. Now with all of that stuff on the camera, here's the camera and here's the audio sources. We just need to move them relative to the camera. We'll go ahead and set their Z and X to 0. And their rotation can be 0. And then what we'll do is we'll set their Y equal to 0. And then we will go ahead and move the one that is related to the front engine. I don't know which one that is. I think it's the last one. Let me move that forward. Why is that? So, oh, the camera is rotated. Okay, that's fine then. We'll move these forward and these back. And this is really very silly. B. Wheatley says the noise is super annoying. Yeah, it is. I'm trying to figure out. I might just do a different noise, but even with a different noise, I need to figure out how to make it sound right. See, the problem is that even if I had a better noise, we still have the basic issue that you can't tell from behind from in front. Your speakers, your headset, unless you're like Dolby 5.1, it just does stereo. It doesn't do complete surround, so you can't hear behind you. And because you can't hear, you know, something that is behind you, you can't tell if it's the noise itself is coming from behind or in front. You can't really get a good sense of where it is. B. Wheatley says he's moved to Boston. Welcome to Boston. If you are not from Boston, then you may not realize that today it is very, 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 very cold. It has been very, 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 very cold for the past month. It is miserable. It is horrible, and it should perk up tomorrow. It should reach above freezing for the first time in, seems like months. So, obviously I'm doing this wrong. The audio is not working properly in terms of how it's supposed to relay the fact that the engines are on. One thing I could do is I could simply delete the reverse engine sound or change it to a different sound effect. B. Wheatley says, am I up in the Boston area too? I am not up in the Boston area. I am up in Boston. Colt Zero is talking about tessellation, if it would be smart to use in tandem to voxels. Well, yeah, as I said, you can use tessellation to just arbitrarily increase the density of any given mesh. Now, if you're using a surface that is non-manifold, if you've got like if you've got things like wrapping around your voxels and caves and stuff, then tessellation gets a little bit dicey. But if you've got a surface that's a membrane and just has to go up and down, you can use tessellation to go up and down by finer and finer amounts the closer to the camera you get, and that works great. Otherwise, you still have problems where your voxels, where there should be holes, there's no holes, or where there is no holes, there should be, or where there is holes, there shouldn't be holes, and stuff like that. And it does get pretty grumpy if you are working with more complex surfaces. So what happens if, instead of this kind of audio source, what happens if I were to pretend that the camera was was something that could be hit? And then what I could do is I could have an audio projection cannon. And if the camera is within the scope of the cannon, then you'll hear that noise that sounds like the engine is blasting grain across you. The problem is that until now I've been operating under the assumption that you're hearing things inside the ship, the cockpit as it were. And I guess I'll try it. I'll go ahead and try it. We'll go ahead and create a new kind of thing, a volumetric gun for our noise maker. Now the problem is we don't have any sort of volumetric gun. We don't have any built-in collider setup for things that are frustrums. We have cubes, but we don't have frustrums. And that's a little bit of a shame, but it's okay. We'll just use cubes. Colt Zero says he thinks it would be good for bark on trees or making surfaces look more rough in general. Yeah, for example, I've used in my test setup for tessellation, I used it for wall surfaces where the walls would be covered in decals. And the decals, when you're far away, would just be bump map things. But as you got close, it would tessellate, and it would use a height map to change the tessellation. So, for example, if someone carved something into a wall, you would be able to actually see the density of the carving. But I don't really know if that's any better than just using LOD. Because, I mean, you can just use LOD and get the same basic results. All right, so here we are in the rocket thruster, and what we're going to do is create an empty object, which is going to be our noise gun. And what we're going to want to do is have our noise gun have something. How about a cube? So if we were to add in a mesh renderer, and then a mesh filter, we can go ahead and put in a cube here. There we go. And drop this back here. There we are. And you can see that right now what we've got is this purple cube. Now, another thing I could do is I could put in a collider. But the problem with colliders is that they collide. So I don't have a dedicated layer for colliders that don't do anything. So we're just going to use a cube, and we'll get the bounds from the cube mesh. And that means that what we'll do is we'll extend this mesh to be the size and shape we want for our noise field. And I'm thinking what we'll do is we'll have two meshes, not just one. So there is going to be our close field, and we're going to want a far field as well. We'll do the far field after, once we've tested this a little bit. So what we're going to want to do is have a small helper script that will turn on our noise field based on whether or not it's colliding with a camera and stuff like that. So we'll go ahead and create that. Call this the noise cannon. And what it does is it just checks and to see whether or not the camera is inside our field of noise. Public void mesh renderer, not public void, just public mesh renderer, target renderer for bounds. And then we're going to want a public we're going to need to have a Unity event, public float event, camera in field. And we're also going to want to have a camera, so protected camera. Here in start, what we'll do is we'll say that camera equals camera.main, and then that will make sure that this is all working. We're going to want a bool, public bool, run by myself equals false. And then here in update, we'll say if run by myself, then test. Public void test. We're going to want to have a couple of varieties of things that we'd want to do here. So public void trigger, float base trigger, and then public float camera field amount. And this camera field amount is what we're going to be doing in order to get the actual camera result. So we're going to go ahead and say vector3 closest equals target renderer for bounds dot closest point closest. We're also going to want to have this something where the problem is that the bounds are rendered as square here, but I don't believe that they're going to stay square now that I'm thinking about it, because yeah, this isn't going to work. So the problem is that as we tilt the ship, the bounds will become a different shape. And that will give us a very, very strange result. So what we're going to want to do is make it so that this is not done this way. We're going to do it a different way. Colt Zero says he wonders if it's faster to generate more triangles from finer grains of voxels or from tessellation. Well, tessellation is orders of magnitude faster, but it doesn't have any more mesh density data. So, for example, if you look at something from far away and it's a solid blob, but as you get closer, it resolves into a blob with holes in it, you're not going to get the holes. You can get a kind of approximation of the holes, but you're going to have a hard time actually figuring that out. So what we're going to want to do is do an on gizmo draw, or on draw gizmos, which will draw the bounds that we are working with, just because otherwise we're going to be screwed. So gizmos.color equals color.pink. Do we not have a pink? Purple? Great. Magenta? Close enough. And then what we'll do is we'll draw a box, a wire box. And the center is going to be our center, but offset. So we're going to have to go ahead and actually set this up a little bit differently because I need to translate the gizmos into our local quaternion. Right, matrix. Matrix 4x4 original equals gizmos.matrix. And then down here we'll say gizmos.matrix equals original. And then here we'll go ahead and say gizmos.matrix equals transform.world to local matrix, I believe. It might be the other way around. I think it might be like local to world. Either way, we'll know pretty soon here. Once the matrix has been successfully created, what we can do is we can draw a wire cube that is offset from what is considered to be just 0, 0, 0, rather than our actual position in space. So our center would just be vector3 dot forward times our scale divided by 2. So it would be transform dot lossy scale dot z divided by 2. And then our size would be a transform.lossy scale. And let's go ahead and see whether that works or if I've got it backwards. So not all camera. Okay, so return 0. That's just a stub for the moment. Okay, so here we have this purple thing, and we need to get rid of this purple thing just because we're not using that anymore. But we have a couple of illegal elements here. Oh, I actually forgot to multiply this one out. We'll just go ahead and multiply it out. TinChaos1 says, how'd your holidays go? Well, I didn't really have any, but I'm taking a long vacation at the end of January, so that's when my holidays are. And Colt Zero is talking about the tessellation. I'm not the person to talk about with tessellation. I mean, if you want to talk to me about it, you can. I'm just going to let you know that I'm not really super familiar with it. I mean, I know the basics of it, but I haven't thought about it in, detail. Oh, except for the scale is going to be, the scale's already part of this, isn't it? So, it's going to be 0.5f and vector 3.1. Cold Zero's done talking about them anyway. Fair enough. So I'm trying to figure out, unfortunately, it's really hard to tell what's going wrong when your gizmos aren't drawing correctly because you don't know where they're supposed to be drawing. And I just never remember whether this is supposed to be local to world or world to local. Or whether or not that's actually even firing. I might have debug.log. Okay, so it's not even firing. I think that I might have spelled on draw gizmos wrong. I don't think so, though. Really, I don't have a noise gun attached. I'm just a fucking idiot. There we are. Yeah, it works fine. So we'll remove this, and now you can see that this is the scale that we're working with. And is it right? Yes, it is. Good. So that is going to be our noise cannon, and we can change the scale by simply scaling it with the brand new widget, which is a fantastic advantage. I am really in love with this new widget. Noise cannon would be an awesome band name. I'm sure that it's already a band name. Yabcat is also asking me the most common question I've ever been asked, which is, why am I not using Visual Studio? Well, Visual Studio requires you to have a Microsoft account, and I don't have one. Most people have a Microsoft account without even realizing it. I do not, because I do not care to give Microsoft my details. However, apparently they are discontinuing MonoDevelop in the next version of Unity, so I will be switching over to JetBrains at some point. Not terribly happy about that. In my opinion, these don't really matter. As long as the IDE works, I don't care which IDE it is. The only reason I don't use the Microsoft IDE is because it requires a login, and that's annoying. So what we're going to do here is we're actually going to want this to be a slightly different construct. So we're going to go ahead and create a new empty prefab, put the noise gun inside of it, drop the noise gun on the empty prefab instead. And then what we're going to do is down here, we're actually going to do this for each of our, for each transform T in transform, each of our children. Now the reason for that is because we're going to be defining multiple child objects to allow us to create non-square noise cannon effects. And we'll just take the best result rather than adding them together. Carlos Cubstar says he doesn't like Microsoft either. I agree. So we'll just go ahead and scale this up to something like this. There we go. And then we will just scale down that part there. And that should be relatively decent for our noise cannon setup. So what we do here is, in order to test and see what sort of noise we've got, we're going to have to go through and test what sort of noise we've got for each of our children. And to do that, what we're going to do is we're going to translate the camera position into our local space. Now the problem with that is that the camera position will have to be looked up several times per frame, and that can get a little bit slow just because it's a reference on a reference. So we're just going to store that. And then what we'll do here is in camera field amount, we'll just test it once. So down here, what we'll do is we'll translate that into the local coordinate space of that new transform. So cam pause equals t dot world to local, inverse transform point. Yeah, inverse transform point, cam pause. And then what we'll do is we'll just test and see whether or not it's inside or outside of our field. Now the way we're going to test that is just by and large it's the z-axis that matters most, but the other axes have to be within 1. So if mathf.abs pause.x is greater than 1, then return 0. If mathf.abs pause.y is greater than 1, return 0. And otherwise, we're going to want to return z. But we actually want to make sure that we need to do this for all three now that I'm thinking about it. There we are. But this one is actually going to be a little bit different. This one's not going to have an abs because z is not being treated in quite the same way. If pause z is greater than 1 or pause z is less than 0. Return 0, otherwise return pause z. That'll give us a value between 0 and 1 based on how far back it is. So it'll be 1 back here and 0 up here. We actually want the inverse of that, so we'll get the inverse. That way, when it's here, it'll be very loud, and when it's back here, it'll be very silent, very quiet. What we're going to need to do is add in a global public float volume equals 1 so that we can multiply that by, our final result can be by that. So here in the camera field amount, we're just going to do for each transform t in transform. And then we will just test our camera field. So float amount equals 0. Amount equals mathf.max amount, comma camera field amount t. And then here we just return amount times our volume. So that should give us a volume based on whether or not the camera is in our fields. And we can have these fields get modified by the volume. But the problem is that that's not going to work The volume, I think we're going to have to modify it based on the every one of these transforms has a different potential volume, right? This one needs to be less loud. But how can we do that? Well, we can always set the name equal to the volume. Now that's a really silly way to do things in the long run. Another way to do it is we can just have it so that it divides by some value based on your index. And that's what we'll do here. Each of these will have a smaller result than the one before. So instead of having a for each here, we're going to have a for int. And then we say transform t equals transform.getChild. A. And then we say that float local amount equals camera field amount t. I recommend spelling things right in general. And then what we'll do is we will modify this local amount by some value here. We'll go ahead and make this local amount times equals 1 divided by a plus 1. So hold on. If I just divide this by local amount divided by equals a plus 1 float. And for some reason, the volume, I still do want the volume because there's an overall volume modifier that would be nice to have. But it's global. All right, so there we have it. The second one will be half as loud, and the third one a third as loud, and so on, which should allow us to create like a static-y field. Another option is that we could have two completely different sound effects, one for the core of the system and one for the exhaust around the core. But that can also be supported by this. It's just a matter of having it work. So here with trigger, what we're going to do is we're just going to go ahead and do a camera in field, camera in field amount, dot invoke, camera in field amount. Come on. Times base trigger. And then up here we have the same thing, but there's no base trigger. So basically this should allow us to test either continually or not how much volume we've got. Now what we can do is set up the noise gun, call this noise gun. We can set up this noise gun to not run by itself, but instead get called very frequently by the other systems. And what we'll do is we'll drop an audio source in here as well. So audio source. The noise gun and the audio source is going to have one of our audio regulators on it. Boom, boom. And the noise gun will call the audio source. Audio regulator regulate. And what we'll do is target render for, I don't need that anymore. Delete. And then the rocket thruster will call the noise gun. Well, this audio probably can't be heard. We're going to go ahead and just increase it just for a moment so that it will be heard or not. You know, we'll deal with that after the fact. I can go up to, oh, it's a reverb zone mix. That's not what I want. But this audio source is going to need to have our sound. So just grab it, audio, engine grumble. Drop it in. loop, volume 0. Save. Yeah, so you know what's going to be a real test is if I were to move ourselves over here. Perfect. Now, the sound effect is bad. I think that what I need is something that sounds like noise being blasted across. So that's what we're going to do next. I'm going to go ahead and blow into the mic, and we'll get a different sound. That's not going to do it because I bumped the mic first. So let's try that again. Oh, I should just drag this over so you can see it. How does that sound? That should be fine. What we're going to do is chop this up like we did before, because that is going to be the same trick we did earlier. Just delete this stuff, and then we'll create a new project, and then we'll copy these and paste them, and then we'll invert them, and then we'll copy them, and then we'll paste them. I think it's a little loud. Let's go ahead and just lower the volume a little. I actually don't know how to reduce the volume. Can I amplify negative? Yeah, I can. I'll just amplify it by -1. Oh, that only did it for one of them. So some of this stuff happens to both, and some of it only happens to one. Fantastic. There we are. And we'll go ahead and export that. We'll call this wind. And Carlos Cubstar, oh, some people are talking about high tech. Oh, he's talking about me creating the noise, I think. Yes, I am super, super high tech here. To be honest, I'm surprised there's not more audio editing on camera. Like, I would think that audio editors would get into this because it's really funny to hear someone blow into the mic or whatever. But the problem is that a lot of audio, actual, like really useful audio stuff, involves creating noises into the mic in a much more controlled manner. And I guess a lot of it is like importing samples and stuff, and it's not nearly as entertaining. But you can still get like audio being played into the stream all the time, and you'd think that would be a natural fit, right? Either way, we're going to switch over to wind just to make sure. That's fine. Carlos Cubstar agrees with me. You know what? That actually sounds really good. Let's go ahead and duplicate that for all the engines, which is surprisingly easy. We'll just go ahead and hit apply. Boom. And now all of our engines should have it. If we go down to another one of these engines, they do not have it because I modified them. God damn it. So what we need to do is revert them. But the problem is that if we revert them, this transform will screw up. So we're going to copy the transform, revert, and then paste the transform. Copy component, revert. Oh, I guess it doesn't change the transform. Hooray! Okay, so I'm not 100% sold on the second noise gun field. I think that I might want to pull it back a little bit further, like this. No, let's hit apply. There we are. Yabcat says, holy shit, this is awesome. I'm not sure when you came in, Yabcat, but thanks. Okay, so why am I not getting any noise? Oh, I pulled it too far back. It's actually behind the camera when it's that far back. Behind the default camera. And we want the opposite. We want it to be just inside of the default camera. So where's our camera default? Let's find out. All right, so we're going to go ahead and give it just a little bit more nuance, because that's a little bit too sudden. So in order to do that, we have two choices. One is we can either slide towards the result, or we can have it based on the X and Y offset as well. So it's fainter towards the outside. I think that that's probably a better idea, so let's go ahead and do that. Right now we're returning 1 minus pos.z. We're going to go ahead and get the value. So float max offset equals mathf.max, mathf.abs pos.x. Oh, I got a better idea. We'll go ahead and say float val equals 1 minus pos.z, like this. And then we will we'll say pos.z equals 0, val times equals pos.magnitude. Return val. That way the edges of our noise field will sound pretty good. Now I'm going to expand the core noise field slightly. It's just a little bit too small. That's not the core one. That's the extended one. Here's the core one. Just like that. That's good. Elboechi says this is a much better sound. Yeah, well, I always knew that I was going to have to work several iterations here. I think it might be a little soft. The good news is I can totally fake amplify it just by changing some of these values, but I think the reason it's soft is because this is set to a 3D mix. If we set it to a 2D mix, and then hit apply, it shouldn't matter where the camera is, right? Let's back up our camera here, just so that we can tell. Try and get our ass directly behind our ship. Okay, I can't hear it. And the reason is because the volume is set to 2.5. So it's definitely giving us a volume, but the volume is super, super low. If the volume was full, I bet it would work. And I think the reason that it's so low is because these are too small. So let's go ahead and... the good news is it doesn't matter how big these bounds are, they'll always work fine. So let's go ahead and make them big, and then apply that. Yeah, with the 2D sound. So I'm not 100% sure that this sounds how I want it to sound, but it sounds. So I think that the main one is still a little too far back. Hold on, how do I want to do this? The problem is that I want the camera to catch more of the noise, so I guess I'll just make this bigger. Because it's kind of like at the moment, and that's not quite right. You see how it freaks out there? Why does it freak out? Let's take a look. The engines are currently on, I believe. But for some reason, we're not getting any audio. If we take a look, this is the lower audio source. The upper audio source is here. There it is. So this audio source is currently set to 0 volume. So where is the camera? Because it should be inside, right? So if we head down to the camera, where's our camera? I think I mounted it to the ship. There it is. Oh, you can see that? Look at that. Let's go ahead and change the parameters here just a little bit more. I think that it's okay if these are too big. I think that it's fine if this is exaggerated beyond belief, because that's something that doesn't really matter in terms of the overall effect. It should be fine. And then this here, we'll pull it back a little bit and radically scale it up. There. And then we'll just apply that. And hopefully that'll give us a little bit more reliable of a noise from our engines, because we were getting a little bit of a floofy sound because the camera was moving through the effect. I know what the problem is. Much better. Also, maybe a little too much now. No, I think it's okay. So we're dividing by this magnitude, which is not really what I want to do. What I want to do is multiply by 1 minus the magnitude, but the magnitude can be higher than 1. So if pos.magnitude is greater than 1, then return val, return 0. Otherwise, return val times 1 minus pos.magnitude. That should work. Yeah, that should work. It'll core out the cube. It won't actually be a cube anymore. It's now a column. But that should be fine. I may have made the range of the noise a little too large in my attempt to fix something that wasn't broken, but I think it's okay. I think it's fine. Ooh, that was unusual. I must have bounced off of something while also spinning the camera. Now, time for the next trick, and that is duplicating it for the side cannons, these here. I'm just not sure whether or not that's a great idea. It might add more computation without adding a whole lot of extra awesomeness, you know? Not 100% sure. Maybe what I'll do is I'll create one noise field system for the triple, rather than one for each. Not simply to minimize the effect, but also to, not just to minimize the load, but also to give the player a little more sense that those are firing when the camera isn't, like, staring at his butt. I can always change it later if I need to. We'll just pop on in here and drop into our strafe jetpack. No, those are supposed to go into the jetpack. There we are. And then we have these same noise guns that we had before. We're going to delete one of these. We don't need them both. And the other one, we're just going to go ahead and zero it out. There we go. And that's the sort of visual that we're currently getting. Let's just use this global modifier and shape it so that it feels a little bit better. That should be fine, right? Maybe a little bit bigger. Yeah, like this. And then we'll shrink it down on this axis. There we are. Alboicha says that collisions are working again. Yeah, they are. They're not perfect. There's some elements to it that could be a little bit better, but basic idea, it works. Robot Sarcasm says, can I ask you a quick question about how you do an effect in this game? You're not working on it right now. Sure, go ahead. I'm always happy to answer questions like that. What we're going to do here is increase the pitch to 1.5. That should give us a different sort of feel to our audio source. Now, all of these maneuvering thrusters are going to need to have that noise gun added as a trigger. There we go. And then we'll just go ahead and save that. Boom. And that should propagate. Yeah, it propagated fine. And let's go ahead and see whether or not we can hear it. Yep. It's very faint though. So what I'm going to do is I'm going to punch up the size of this field. Yeah, that's not too bad. Robotic Sarcasm is talking about this grid here, which is that. He's talking about that. That's really a core part of the experience, and I spent a lot of time trying to get it right, and it's still not quite right. I'll be changing it again later. His question is, do you use screen space projection for that? No, I thought about it, and I decided I didn't like the idea of screen space projection, just because I wanted each physical object in the game to feel like it existed as something that was being scanned, rather than as something that was on your HUD. So I use world coordinates for that, but unfortunately I don't do a real great job at it, and that's why we have some of these that are not quite as nice as others. So for example, if we come down here, oops. If we come down here, you can see how we have some weird choppy effects. It's not really a grid all the time. Sometimes it's like a weird spiky thing. That's just because my math is bad and I need to fix it. Robotic Sarcasm says you can get world space coordinates in an image effect though. Oh yeah. Yeah, I use it as a shader rather than a post effect. Have you tried doing triplanar mapping for it? Yes, that was my first instinct. So let me show you the problem with triplanar mapping. When you're approaching an object like this, what you'll get is you'll get some moment where the object is at precisely 0 away from some integral thing. So for example, if you're drawing it every meter, you're drawing like a grid point every meter, at some point there is going to be a moment when the surface of the object is exactly on that meter line. And you see how that pulsed? That kind of pulsing happens a lot, and it ends up being, instead of a grid, it's just like a flat block of color. So I did this specifically to avoid getting the giant flat block of color that you get when you use triplanar mapping. I've tried to figure out some other approaches. I haven't really thought of one I prefer yet, but this is something that can be changed very, very easily, so I'm not too concerned about it. I'll just keep changing it. Someday in the future, when I get around to it and I decide I want to see something a little bit different, I can change it without any difficulty. So the shader in question is this guy, I believe. And down here, we've got this, and this is how it all works. So you find the polar coordinates and you try and draw circles. But all of this is largely to try and keep it from ever being a giant block of color. And I think that there are probably better ways to do it. I haven't really thought it out well enough. It's just one. I did it for like one session. So Robotic Sarcasm says you use a per object shader. It's a global shader. It's just a shader. It's per object in that it is put on objects. But I mean, all those objects have the same material to the extent where they're actually all packaged up in a single GPU draw call. So it's just a shader. It's nothing per object about it. But if I was doing it with something that was more complicated, like a screen effect, then when I try and do it for particles like this, you see how these turn yellow as I get close? Like this. That would be hard to do if I was doing it as a screen effect, which is why I went with a shader. So the reason that noise is playing right now is because any collision counts as a noise-causing collision, even if the collision is a pull collision. So I have to change that so that the pull effect doesn't actually make a popcorn noise. But I might have it make a different noise. Maybe I can use the engine grumble for that. So I also need a ping for the radar. So I've got a couple of things that I need to make noises for. Let's go ahead and do the popcorn situation right now, just because that one's what's on my mind at the moment. The magnet that we're using is just this thing mounted on front of the ship here. This one. Here it is. But the problem is that this still sends noise back to our friends. So in order to not have this actually make noise, we need to change how it reports back to the fundamental call, which is on the, I believe it's on the cheap collider pusher. Draw instanced base. Here it is. So the problem is that the draw instanced base will actually still give you noise. And that is not really a great look. So what we're going to do is we're going to just go ahead and say if pull return 0, no noise hack. Robotic Sarcasm decided he was finally going to follow me after showing up for like a year. So well, let's go over to some place where there are debris where we can magnet them. They're still making noise. So here's the cheap collider pusher. It's really very, very basic. So where is the noise coming from? It's coming from inside our instanced mesh set, isn't it? Yeah, here it is. Robotic Sarcasm says that at least now I know that the Twitter and YouTube announcements actually work, because otherwise he wouldn't have shown up. Yeah, I'm never sure what sort of announcements to make. I'm not a pro at this sort of thing, so I guess I'll just keep it up as it is. It's mostly to just help keep me focused anyway, right? Right, good. So now it's no longer making noises, but what we do need to do is to have this delete have a sound effect, and it's going to want to have like a zap or a vzap or something similar. So let's go ahead and create some new audio. Zap. That was too loud. Try again without the loudness. Zap. There we are. That's better. Okay, zoom in, zoom in. Zoom in, zoom in, zoom in. Hello, can I get a zoom in? How do you zoom in? Zoom in. Wow, this is obnoxious. How do you fucking zoom? How do you zoom in? I know there's a way to do it because I've done it accidentally before, but it doesn't appear that it wants me to do it. What the hell? Just... Control scroll. Okay, that worked. There we are. So what we need to do is make it so it doesn't sound like me saying zap. And there's a lot of ways to do that. First off, we're going to change the pitch so that it's going to go up. Do I want to make it go up? Maybe what we'll do is we'll duplicate it and have several layers. So this one, we'll have it go up. Change pitch. Up. Oh, that did it to both. Mag glass, Carlos Cubstar says. I don't know what that means. Sorry. But once again, it's happening to both of these. I don't really know why some effects only affect one of these and some effects affect multiple. Is it if you've got it selected? Is that what it is? Yeah, okay. So if you got it selected, it works. Zap. 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 And then up here, we'll have like this turn into a molten, grumbling noise. Nope, that went the wrong way. Let's reverse it. And then we'll also change it to be a different pitch. No, that was 75, something like that, yeah. So hold on. That doesn't sound like it's going the correct direction. That's creepy. So for some reason, it's not actually taking the change pitch. When I try and bring it down, oh, okay, percent change goes negative. So that means that this guy up here is really, really high. So let's go ahead and, great. Here we are. Let's change this pitch by something other than magnitudes, that kind of magnitude. I will make it 100. Just double it. And then this guy, again, reverse it. And add in that change pitch, jump to -50. And then we'll just see how that sounds. Just so the problem is I changed the pitch here when I actually wanted to change the speed. Yeah, so we'll undo. Effect change speed. There we go. Boom. That's why I was so confused. And then again, we'll want to reverse it and change the speed. And then this can be moved quite substantially to the left. Can we just like, there, much more left. There we are. Well, that doesn't sound very convincing. Let's see if we can make it sound more like a sizzle. So if we want to make it sound like a sizzle, should we phaser it? I don't really know what half of these do. try echo. Now, does the echo actually add to the end of it? Does not. Okay, so we have to add in, somehow we have to add in more silence here. Can we generate silence? There we are. Maybe that'll do. And then what we'll do is we'll add, we'll add in the, wasn't there an echo? There it is. No, it doesn't sound anything like a sizzle at all. Just start over. All right, now let's go ahead and modify this. So if we add in an echo here, boom, how does that sound? No, that's not it at all. What if we add in, what is a phaser anyway? I don't even know what this does, but it just seems to turn everything down. Reverb? No. I don't really know what the sound of sizzling metal is supposed to sound like. We're shooting it with a big laser. Oh, phaser makes it move left and right. Oh, that makes sense. It's also not what we need. Let's see if we get a high-pass filter here. That made no difference. What's a notch filter? I think that cuts out frequencies in the middle somewhere. We do have a couple of options for generating noise, where we can generate a chirp, a noise, silence. Let's go ahead and generate some noise. No, on a new track. Yeah, like that. So what's this chirp? That is not a chirp. That's a frigging sound effect from, what's it called? Back in ye old days. An Atari sound effect. No, generate. Did I accidentally hit DTMF tones instead of chirp? That might be it. No, it's definitely... Yeah, that's not going to work. Ouch. I'm just kind of playing around trying to figure out what a sizzle might sound like, but I think what I want is noise. Yeah, so if I take this noise and I just play a small amount of white noise, I think that's going to be better than me speaking into the mic. So we're just going to delete an arbitrary amount of noise here. Now, can we go ahead and clamp it so that it fades out and fades in? We can. That's good. And then fade out. That's good. Sounds like a wave. So we want to fade in substantially faster. Does that mean we just select a smaller amount of fading here? Fade in, and then we want to fade out. We'll fade out over the whole thing. I want a fade out that's not quite that... I want it to fade out in a different way. So maybe I can just force it to fade out. Can we change this to just be shorter? I think that's 5 seconds, isn't it? 5 seconds is way too long. We want it to be like 1 second. And we'll fade in and then fade out. Fade in. Fade out. And then we'll fade out again. Yeah, there, that's fine. That'll be a good sizzle. export audio, sizzle. And so what we're going to want to do is when we burn it, we're going to want to put up a sizzle instead of whatever we're doing now, which is nothing, I believe. Here, we got this delete within. Right now we do this clank sound emitter, emit, blah, 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 blah. We're going to want to go ahead and have a similar thing down here for our deleting. So when we actually move into this, we just going to take a look here. We have no velocity, magnitude, or any of that stuff. This gives us a different volume depending on how fast we're going. That's not something we need to care about. And then this would be mass. So we're going to go ahead and pass it a range dot normalized, I guess. It should be just in the front almost all the time. But what we're going to actually we're going to want to make that. I guess we'll just try it like this. But the problem is the clank sound emitter doesn't take a specific sound. It only takes a generic sound. So if we were to close everything else here and then open up this clank sound emitter, you can see that we have an audio pool, right? But what we don't have is a way to specify different kinds of sounds. So Minecraft's item falling into lava sound, pretty much. So what we're needing to do is we need to have the clank sound emitter emit a variety of different sounds with a variety of different feels. And that means we're going to need a new class, public class, clank sound emitter sound pack. And that's going to contain an audio pool. And it's also going to contain a tag. And that's going to be a serializable. And what we're going to want to do here is have a public static. Okay, so hold on. It's not an audio pool. My bad. It's options. See here, clank options. This is what we're looking for. There we are. And then we're going to go ahead and copy this, put it in here. And then we're going to want to have a list of those instead of this. So public list, clank sound emitter pack, sound packs. And then this isn't going to be what we need at all. We're just going to delete it and have the errors tell us where to go. But we're going to want to have this a similar thing where it's actually an argument. So audio clip. It's a function with an argument, so get audio string tag. If tag equals 0, return, or tag equals quotes, or tag equals null, then we're going to want to return the first pack, sound packs 0 dot audio clip. For each clank sound emitter pack p in sound packs, if p dot tag equals tag, return p dot audio clip. Otherwise, there you go. And that's what we're going to do. We're going to replace this get audio with this audio clip with a get audio and a tag. Now, obviously, we don't currently have a tag. I mean, we do, but it's the wrong thing. So we're going to have a string tag with a clank. There we are. Actually, we're going to go ahead and use these not as strings. We're not going to have strings. Just because they would be calculated dozens of times per frame. And that's not good. So what we're going to do here is just use integer values for your tags. There we are. And now we'll have to go find that clank sound emitter, which I think is mounted on the camera. Oh, there's an error. Oh, yeah, that's no longer needed. You got any more errors for me? No. So we go over to the camera and we take a look at the ship audio source, clank sound emitter, and here are our sound packs, and we're going to go ahead and have a size of 2 here. And the first one's just going to have that clunk that we're currently, the popcorn clunk. Which one was the popcorn clunk? That one? I think it was that one. No, it was that one. Okay. We're going to change this one to a... this one's going to be a thump. And this one will be a thunk. We'll call it popcorn thunk. Now, back to the camera. Popcorn thunk. Oh, come on. And then this one is going to be the sizzle. That's not how you spell sizzle. There we are. Save that, and then we'll pop on over here into the clank sound emitter, and we will just pass it a different argument so that it knows what we're clanking for. Here it is. It doesn't look like the clank sound emitter emit has been properly saved, because that's not giving us that final argument. Oh, because it's underscore emit. That's right. So we need to go up here to emit, int tag equals 0, and then tag. Popcorn Thunk opened for Noise Cannon on our last tour. Yep. Yeah, the Creeper idle sound would be more applicable, but I don't know how to make it. I'm not very good with audio. I don't have any audio sense in my brain. I can't hear it before I make it. All right, well, let's go burn up some stuff and see whether or not we get a good sound. Yeah, that'll work. Okay, so now it stopped for some reason. Huh. So we're gonna delete this sizzle here. So for some reason, the sizzle sound effect stopped happening. If we take a look at the popcorn thump and the sizzle, I think that they're comparable. Yeah, they're comparable. So I'm not sure why the sizzle stopped working, but the popcorn thump didn't stop working. Maybe there's something wrong with the pooling. So this overrides controllable ship system update. So if can we override that? I see. So I actually changed how this works. The controllable ship system has a different kind of update. This is the radar that we're going to work on next anyway, so we might as well be here. I changed how the controllable ship system works, in that now you can tell it to wait for specific buttons and stuff like that. And the radar currently doesn't have that setup working. But what we can do here is replace that with a better version, which will be in our activate. So we're no longer going to check and see this at all. Instead, what we're going to do is if we are firing, we're updating. So we'll just... And let's just pop on over into the definition here. Make sure that I'm not mistaking something. So the controlled update just looks and sees whether or not any of the specified controls have been clicked. That's correct. We're going to need to go ahead and override update as well. Here's activate, and this is on activate, invoke, on deactivate, invoke, blah, 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 blah. That's all good. We're going to need a little bit more complicated stuff going on here with the activate because if the player holds it down, I don't want to reset it every single time. So if not scanning, so we're going to say if amount is greater than 0, if not scanning, scan. Else, turn off. Scanning equals false. And then here we're going to have override update. Controlled update? No, we want to override the actual update. Yeah, we should have that option. Did I just mistype it? Let's try that again here. Huh, why isn't it giving me the... Oh, because I've already got a function called update. There we are. We do want to call the base update, and then we'll do this part. So this is not what we need here. We just need to go down to if scanning, blah, 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 blah. What we're going to want to do is emit a radar ping when we first scan. And that's not too bad because we actually should have an event for it. So let's go ahead and create an event for when we fire it. Public Unity event on radar fired. And then down here we'll say on radar fired dot invoke. So now our radar has the ability to emit a beep. The rotor update also has that problem, but we don't care about the rotor or the scanner at the moment. We'll deal with them later. So where is our ship? I can see it much clearer than I used to be able to because now it's surrounded by purple. So if we go over here and we get nice and close, the scanner is here. And what we're going to want to do is add in some elements. So here is the controllable ship system. That's the magnet. That's not the radar. The radar is this guy, isn't it? Radar. We're going to want to have the same basic setup for the magnet as well, but it'll have a different sound effect. So what we're going to do for the radar is go ahead and have an audio we're just going to go ahead and have it go ping. The problem is it's not going to be affected by your audio volume. It's just going to be a standalone noise. We'll deal with that later. We'll make it have a we'll make it have an audio that changes volume with your master volume controls later on. We'll work on that. For now, however, we're just going to go ahead and create the beep. 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 Okay, so let's go ahead and see whether or not we can make that sound a little bit more interesting. Beep. We're going to want to make it so it sounds a little bit less like me. So and the problem is that b, but that's okay. It's actually not too bad at the moment. It doesn't sound anything like a real beep does, but I'm okay with that. What we might want to do is, what's an auto duck? The auto duck needs a control track. Oh, that's what it does. That's good. I don't need it though. So what we're going to want to do is, ooh, what's invert? I think that just changed which was left channel and which was right channel. Yeah. So if we were then going to do something else, what's a Paul stretch? I guess it just stretches the audio. To be honest, that's actually pretty close to what I need. What I do need, however, is to radically boost the volume on this first section. It's far too soft in the beginning. Can I do a... can I do an amplify? But the problem is I want it to... Oh, good. Did that work? I don't think so, actually. I think it screwed up. Yeah, there's a big step right there. You can see that step. I don't want that step. But if I select the whole thing and I amplify the whole thing, like this, like that, and then I do a play. Supafcan says that that there really shouldn't be anything noticeable about invert. The only thing I really want to do now is I think I poly stretched it a little bit too much. So let's just change the speed to double. There we are. Close enough. And then what we'll do is we'll do a fade out. There. Good enough. And then what we're going to want to do is export that audio as a ping. And then we'll drop that ping into this new audio clip. No loop, no play on awake. 2D so that we'll hear it regardless. And then we'll just tell the radar audio source.play. Play. All right, let's go ahead and try it on for size. Oh, I forgot to tell it that currently it doesn't actually fire. There's no fire button for it. So let's go ahead and set that up. We're going to need to set up a button here in input. We got a fire 1. That would be mouse 0, joystick button 0. Fire 2 is mouse 1, which is the camera control, and that's not going to work. So we might make this space. We can also make this middle mouse click. I don't know what that is. Is that mouse 3? I don't actually know. I'll leave it like that. And we'll have fire 2 be what actually triggers our radar. It doesn't look like the radar actually works, but the noise works. It worked. All right, so I'm going to make the radar fire much, much faster. That's a very slow radar. It takes 3 full seconds. We're going to make it take 1 second. That way we'll get a nice, good response. It sounds radar-y. Yes, that's the truth. Guard says that he would like it a lower pitch. Well, we can go ahead and try it. Let's go ahead and just see what it sounds like with a lower pitch. You know what? I think you're right. I think that does sound better. Export audio. We'll call this a low ping. And then we'll run away and get married. All right, so the audio here in this, we'll just take this low ping and stick it in. Which do you guys like, the low or the high? Here's the low. Here's the low. And then here's the high. I think the low might be a little bit better. High is actually better on second, though. Thought. Okay, so you like the high better. Robotic Sarcasm likes the low.
In the end, I might use different effects depending on the kind of radar you have, but that should work for now. The other problem is that we've got this pop-up on the right-hand side, which responds to space, and that's not going to work. So let's go ahead and find that help panel. Input button space. See that? We're going to go ahead and remove that. So that's also going to be F1. F1. There we are. Guard says it sounds like it's underwater, but most of the other people seem to think that low is better. Carlos wants them blended together. They're literally the same sound at different pitches. So I'm not sure that that would even be noticeable. It would just be louder. Oh, well, it would actually be a chorus, wouldn't it? Let's go ahead and try it. So if I copy this, and then I undo it. There we are. And then I paste. You want a little chorus sound effect? That actually doesn't sound too bad. Let's go ahead and turn the volume down a little bit for both. They're the high-pitched one and the low-pitched one. Are they offset? I think they are. No, they're not off. They are a little bit offset. That's a little odd. Let's go ahead and turn the high-pitched beep down a little bit. And -2. And then the low-pitch beep down a little bit. -1. Because we don't want to max out the sound. Well, I'll give it a shot. So if we export that audio, we'll call this a choral ping. And let's go ahead and see how that sounds when we put it into our audio source. I'm actually not sure. Let's go ahead and take a look here. This is the low ping. High ping. Choral ping. I actually think I might like it better as the low ping or the high ping. It sounds a little too complicated with the chorus. Unless I were to turn down this volume even more. Oh, is this the... I've got it backwards. I got the high and the low backwards. No wonder it was sounding a little odd. The original source with me going ping. Yeah, I think you're right. That might work. No, that was the high. Let's not overwrite that. Let's overwrite the choral ping. Hold on. I accidentally have one thing selected. I don't want to accidentally select just one of those. There we are. There we are. Let's put the choral ping back in. I think it's already in. You know, I think I like that. You're right. It has just enough of a chirp to it that it sounds fun. Now, Guard says, "Oh God, that's great. You managed to do that from there," but I'm not sure what he's talking about. Dr. Speck Potato says that chat's always right, except when they're not. All right, we've come a long way. This version is I'm going to go ahead and release it a little bit later today. So if you wanted to play it, you will be able to. I just have to compile it and reload it. Okay, so there's something wrong. when I let go and then re-click. Okay, well that's fine. I don't care if there's only a couple of small errors. We'll figure it out later. The other thing I wanted to fix is that when I reverse the pilot ring looks bad. So we're going to want to have this. We don't want that anymore. Just remove that. The pilot ring visual, I think the adaptive material is what reverses it. Right? Here, see this? So what we're going to want to do is not have that happen. I was using it as a... so we're going to go ahead and... There we go. As long as we're not, yeah, 2 is distinctly better than this. That should all be fine. Let's try it out. I think that we're going to end up with something a little bit unexpected, though. So, what? Did I not want to delete the pilot rings? Don't rotate? I must actually have been using that after all. Be more careful, Craig, because you're apparently an idiot. So there it is. Ship.transform.forward pilot ring. So for some reason the pilot ring, when I deleted the pilot ring, don't rotate with parent, and then I undid it, it didn't undo the reference. That's annoying, but whatever. So people actually have said a lot of stuff. Sorry, I wasn't paying attention. Guard says he liked how I turned saying ping into an actual ping. Guard says, what's that bright ball again? It's a cleanup ball I just created to make it more like Katamari Damacy. You magnet stuff in and then weld it. It's definitely now a lot more useful. Okay, so you can see how when you rewind, when you back up, it no longer flings stuff behind you, but it's noticeably a shorter distance, and that's fine. So the last thing we need is a wub 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 for the magnet. To be honest, we have a low drone. Is that going to be good enough? Is that engine growl? Yeah, that'll work. So what we'll do is we'll put that engine growl in as the audio source for our magnet scanner. Here it is. So just drop it in the same spot. And change that to the engine grumble and turn on loop. And then that will be like a when we are trying to scan. So what we'll do is we'll turn this so that it does different things depending on what's going on. Our overall controllable ship system for the radar, you can see that what it does is it turns on the various pushers and stuff. We're going to want to have it turn on the audio source as well. Oh, there is in fact an empty slot for some reason. For the basic sound effect, that's probably not a very good fit, but I have it, and it works. So I'll be redoing a lot of these sounds again later. For now, I just want it to sound like something's actually happening, you know? So one of the issues is that this no longer contains the information that you need in order to play it. So here you can see tap left mouse to send out a pulse and that sort of stuff. We need to replace that information. So that's what we're going to do. We're going to go into the help system. And where is our help panel? There it is. And the help panel should have a block of text. Is that in the text box itself? It is. There we are. No, that's not it. Oh, that's the wrong help panel. I've got two help panels. The other one's over here. There it is. So tap left mouse, or hold left mouse to use your magnet and welder to clear loose debris. Tap space to fire your radar to look for spare parts. Good. Did that actually take? Yeah. Bye, guard. Kyran123 says that this game looks hella fancy. It's barely started, but the tech is all here. It's just a matter of turning it into a game. Oh, that actually records a GIF. Okay, I have to turn off the GIF recording. I have hundreds of GIFs now backed up in my main directory because I wasn't paying attention. I forgot to turn the GIF capture off. I don't want to release it with the GIF capture on for certain. Ah, stop that. I have temporal sampling on, and I don't think I meant to. I don't know whether I clicked on that or not. It should be fine. Should be fine. There. No more saving GIFs with every time I send out a radar pulse. But for some reason, the GIF isn't capturing these guys. Rather, the radar doesn't seem to have a very long range. I think the range might have been decreased. 10,000 is not decreased. That's quite large. So why isn't it detecting everything within that range? Does it not scan the first time and only the second time? There it is. Well, it needs work for sure. Oh yeah, the only other thing I wanted to do, right now when we are doing the thruster calculations, we are doing them with the wrong priority. So let's go ahead and open up the thruster. So right now, when we're trying to determine which direction we're trying to fire, what we do is we try and maneuver. Here it is. Handles both turning and strafing, but right now it is radically more affected by strafing than by turning, which leads them to sometimes looking like they're firing in the wrong direction. So what we're going to want to do here is we're going to want to add this at just 0.1f. Because otherwise they always look like they're firing the wrong way, which is very dumb. See how they're firing on the wrong side there? That's because they're trying to bring us back into strafing. But the strafing, I just turned the strafing way down and it's still firing too much. What if we just multiply it by 0? Is this actually not... No, it is delta. Okay. So that works. So even at 0.1, it is too much. So let's try 0.01. These vectors are kind of arbitrary, and they're based on a whole bunch of random old physics stuff that got taken out. So it's not really a big surprise that they don't make any sense. Yeah, that's more like what I want. Now, you can see they still do fire just fine if we strafe. Yeah. It would make a little bit more sense visually if we had 2 sets, one on the back of the ship and one on the front. There's no reason not to do that, so let's go ahead and pop on down to the ship and duplicate some of these thrusters, because the thrusters could stand to be a little bit more everywhere-ish. So we'll put one here, and you know what? I think that'll do. Let's try it out just like that. So now, when we rotate, you can see how they fire in opposite directions. But when we strafe, you see how they fire in the same direction. That'll give us a lot more visual feel for it, you know? Now, the only problem is that it's going to make us a lot snappier than we were a second ago. We turn a lot faster, because we have 50% more thrust. But I think that's okay. Turning speed was maybe a little sluggish before anyway. I can always switch it up later if I need to. Good, good. So I'm going to go ahead and sign off, and we're going to compile this off screen, because there's always some stupid glitching compilation and zipping up, and you don't want to watch that. But I will be back on Wednesday, and if you can wait maybe an hour, this will be uploaded. The new version will be uploaded, and you'll be able to do it with all the sound effects and the welding and that sort of stuff. So have a good one, and I am going to see some of you on Wednesday or next Sunday.